So let's take a look at this and see what we will and won't need to make this ready for digital operation. We won't be using the light bulb. I'm going to replace that with an LED. We will not be needing this diode that's down here. We're going to have to separate this direct connection from the pickup to the motor, and we're going to have to remove this it's probably capacitor that doesn't work with a digital layout. We have the pickup here. The pickups are actually spread nicely through the length of this locomotive. On this side, same thing. We have the pickup here. We have the pickup down here. I am going to put a light bulb, or rather an LED, on the front as well as the back while we're in here. Make it directional, and plenty of room to put a decoder right here. If I ever decide to make it with sound, there's even enough room to put a speaker there. So first we need to determine where the power pickup is and where we need to separate the power pickup where it is connected directly to the motor. So let's start with this rear axle. We have a plastic hub on this wheel, we have the contact, and we have a metal to metal contact between the wheel flange and the axle. So this one connects to this underneath it and connects to this wire right here. This one is then connected to the motor, and because this side is insulated and this side is connected, there has to be a connection between these wheels and these wheels on this side. So if you follow this connection on the motor to the other side, it does indeed connect to these two pickups. This separate wire right here goes to the diode, which goes to the light bulb, which we're going to control digitally. For the other side, we have a plastic hub wheel here, and we have a metal flange onto a metal axle connecting to the contact, which connects to here, which then has a wire soldered here, which connects to these two wheels, which is correct, and then that goes directly to this side of the motor. So simplicity at its finest here from Lima. Should be no problem to simply disconnect it at the motor right here and provide the power input to the decoder, and then from the decoder go to the motor and have the directional lighting. We're going to start by removing the light bulb. So the light bulb is powered from the top here and then from the bottom right there. That's the positive current, and then the negative one comes from the base here. So we're going to turn this to get that contact out of the way and take out the light bulb, hopefully with a little persuasion. There we go. So I'm going to save that because they're kind of unique. And so now we have the two currents right here. We have this one providing power and this one providing the ground. So we need to make sure that they don't touch, because we're not going to be using either one of them when we put an LED in there. I want to minimize any damage. I certainly don't want to go wrecking around with this to convert it, so we're going to try and unsolder as much as possible, starting with this diode right here. That comes off, and that wire there. Let's turn it around. I don't want to put the soldering gun so close to that plastic gear, so I'm going just going to cut that wire off right where? Right here. So now we have the diode out of the way, and we're ready to continue. So again, since I don't want to destroy too much and I don't want to solder too close to these plastic components, I'm going to try and save what I can. So I'm going to cut this wire here. So then this will be the power input to the decoder from this pickup in here. This will be the power input to the motor. Then I have the power input from here and here I will cut this one close here, and then this one I will leave a little stubby piece of wire, and then these two will be power input to the decoder, as will this one, and then these two will be the power to the motor. For the lighting, I do have 1990s or even 80s technology fiber optics here, where it feeds power to those three lights, and the same thing on the back, which was not utilized at the time, but I'm going to utilize it now. I tried a couple different LEDs to see what I liked for the lighting on here, but nothing really gave me the effect I wanted, primarily because LEDs don't really glow. They more project a direct beam, and so unless they're directly behind the lens, it just has a very, very faint lighting effect. So what I did is I switched to grain of wheat bulbs, front and back, and I'm going to see how that works. If I don't like it, then not much lost. I can still take them out and do something different, but that's how I'm going to proceed from now. Instead of soldering the decoder directly into the locomotive wiring, I'm going to put this pigtail harness in the locomotive, and that's going to allow me to plug the decoder into it, and then if I need to change something, I'll have plenty of wire left, and I can always unplug the decoder and replace it if necessary. So to prepare for the decoder pigtail installation, we're going to start by shortening these extra wires, and we'll just cut them off here and here. Save those wires for later because they can always come in handy. The power input wires for the decoder are the red and black wires right here. So we need to connect them to this wire on the one side, and then this one and this one need to connect together to go to the other wire. To strip these wires, you can just use your fingernails. It is really easy. If you use a stripping tool, you're more than likely going to damage it. So we just need to find a place for this connector and then start soldering some wires. So my connector is going to go somewhere in this area right here. I'm not sure if I'm even going to have to glue it down. And then my two input leads are going to go over here and over here. So this is all the wire I'm going to need. I do need to check with that ballast in place if that's going to interrupt it. We can make it a little longer. We'll cut them right here. Like I said, strip them with your nails. Because the strip tool will more than likely just cut them. I'm going to use my thinnest 1.5mm shrink tube. So we'll get a piece of that ready. And let's tin those wires and get them connected. Let's tin the wires so that they'll be ready to connect. Like so. I'm going to start by twisting these two together so that they're as one, and that means we can also cut them a little shorter. Alright. Next we slide the shrink tube over the two power leads going to the connector. Get them out of the way. Now we're going to take one of these leads and solder it on there. Doesn't matter which one at this point, that's just the AC input. Like that for this one, and the one in the back here. like so. Now we slide the shrink tube over the solder connections we just made. Like so. And the one in the back. And that's that. Now that those two are done, we need to make our motor connections. For that we left these two little stubby wires. And we need to figure out how much wire we need to reach them. The connections for the motor are orange and gray. So we have our orange wire here and our gray wire here. And if they're going to be here, they need to be about this long. So we're going to cut them off here. Strip them with your nails again. Now we're going to tin those wires as well. I forgot to mention that I did take that capacitor out that used to sit right in between the two terminals. That's there pretty much as a noise suppressor when it was operating in analog DC mode. But with a decoder, it's no longer needed and can actually cause interference with its proper operation too. So let's tin these wires. Down here on the motor as well. And we're ready for the shrink tube. Now we're ready to solder those two wires. Like so. And once again we slide the shrink tube over the fresh solder joints we just made. And we shrink them down. And like that. Now we're ready to start hooking up some lights.